Okay, continuing where we left off from earlier, we had a very simple model. We have no knowledge of where the elements are at this point, and we'll look at that in just a minute. Got a stress concentration of 1.33. I guess to my eye, just guesstimating what's happening here, I almost see a stress concentration right around 4. And 1.33 would be, here is a 1, the middle of this line vertically would be a 1.2. This line hits almost on 1.3-ish. So 1.33 would be right about where my mouse is. And that looks a little lower than I might have guessed, because I would see this line extending out a touch higher. So don't know if any changes we make will have a big change in this number right here, 6390, because that is the highest stress. But let's go see what happens. I'll also move the calculator out of the way. And let's close our results window. No, I won't save any changes, but we'll remember that 6390. And so now I'm going to make some refinement to the mesh, is what I'm going to do. And so I'm going to go into AutoGem, Control, and we'll go with Surfaces. And I'm going to select that surface and that surface. And I'm going to put a fairly small element on those surfaces. I got to click again. 0.03. Element size, fairly small element size, and we'll take a look at that element size. What I didn't do earlier was look at the element size for this thing before I made any changes. I believe it used 2 elements for this. So 1 element right around that hole, going all the way to this corner. 2 elements total. Well, we're going to get a lot more elements now with what I've just done. And so we will now run again with only that change. Run, yes, no. See the results as they go. Taking a little bit longer. It hasn't finished generating the elements yet. Let's see. I guess the other thing to remember is I've only got my accuracy at a 0.5 right now. And so actually I'm going to cancel this. Let's close this. I'm going to stop it. Really want to stop it? Yes. I'm going to go bring my accuracy down to an insane level, 0.01. That is absolutely insane. Okay. Yes. Now let's run. What that will force is it to run with all the accuracy that it can. Yes, no. And we sit and we wait a few minutes while this thing runs, and we'll just try to keep an eye on this thing. So we have 6,300 elements in this thing. That's a little surprising that we have that many elements. Our equations, 5109 equations. That's a little surprising that it's that small. But moving to 32,000 equations for the next pass. Third pass, 229,000 equations. That's a big jump in the number of equations from 32,000 to 229,000. And we wait for the equation solver to do its thing. I will try to remember to show you one other thing that would be helpful. I probably am not taking advantage of all the memory that I own in this computer. My guess is that it's trying to use the default amount of memory, which is something like 128 megabytes. And I suspect I can give this model at least a gig to run on, because I think this computer has 2 gig, not 4. But we'll see in a moment. But I ought to be able to give it more memory than it has available to it. but we would expect 229,000 equations to take a long time. Matter of fact, what I'm going to do is just pause this movie and I'll come back once it's converged. Okay, we are back and the model has converged finally. And this thing ended up taking a couple of hours to finish. If we look at some information here, 1446, so that'd be 2:46 p.m. And looking at these timestamps down here, 16:36 p.m. Is when it finally pretty much finished. So just under 2 hours to finish this analysis, which makes me think for this purpose, at least for the purpose of teaching, I may have made the elements too small. But let's go take a look at the answer. And we can look at display options. Let's go ahead and turn on the elements. OK, and show. And we see plenty of elements on this face, a lot more than is necessary, probably. What we can do now, though, is run this with fewer elements and just back off and compare now that we have this answer. 6487 high stress with a nominal stress of 4,800 that we calculated earlier. Let's grab the calculator, get a stress concentration factor, bring the calculator into view. So 6487 divided by 4,800 is a 1.35 stress concentration. 1.35 on this 0.5 line is still right about there. Let's see, 1.2 would be there. 1.3 would be awfully close to there, so 1.35 is right about there. And it doesn't have the same gap that these have, but it still could very well be the truth. Let's move this back out of the way, move this out of the way. Before we do that, let's store that 6487. 6487, memory clear, memory plus. That way we'll have that around next time when we get another answer. So let's back off on that mesh size, run something that won't take nearly so long. You want to save current results? No. And let's go to the AutoGem. I wonder if I can edit this definition. Select it, edit definition. It appears I can. So let's go with a 0.1. And we'll see how that behaves. And that's still not going to be amazingly fast to run, but it should be certainly faster than we did a moment ago. So we will now run the analysis. Run it. Yes. No. See what's happening here. Pass 1, pass 2. Well, these are certainly moving faster. It is going to have to go. Let's see, this is element 4, order 5. So we still have 6, 7, 8, and 9. So 5, 6, 7, we have passes 5, 6, 7, and 8 possibly. And equations are moving upward a bit, but still not horrible. This one may be a 5 or 10 minute run. So I'm going to go ahead and pause this one until the analysis is done. Okay, this analysis has finished, so I'm back, and let's take a look at the time for this one. We started off at 9:10, and we finished up at 9:14, so about 4 minutes total to finish this one. We will close it. Actually, no, let's open it back up again. Let's just take a look at that top von Mises stress, because that's what we're really interested in. So max stress von Mises 6488, and for the run that took over nearly 2 hours, we had 6487, so we clearly didn't get anything of value out of that extra time that was spent. Of course, an interesting question now is, can we make the elements bigger and still see that same kind of accuracy? So we'll play with this just one more time, and I will go and click on the element size, right click, edit definition, and let's try a 0.25 and see what we get. Okay, I expect this one to run pretty quickly. Run, yes, no, watch the results. 1, 2, 3, 4, 5, and 6. Max edge order 7. Past 7, max edge order 8. Guess we'll let the video roll because this one's not going to take all that long to finish. Well, it's taken long enough. I will go ahead and pause the video just to save video time. Okay, we're back. This one has completed. It didn't take very long. And let's go take a look at, let's look at the time involved. 9:21. Let's see, 9:21:12. And 9:22:30. So about a minute and a half, 9:22:38, minute and a half for the total thing. And checking out our max von Mises stress. Where is it? Max stress von Mises, 6487, 6488. It is still very much where we were with the run that took 2 hours. And so I definitely went overkill on that initial mesh size. I think we will stop this analysis there. Let's go ahead and look at the results. And let's turn on the deformed shape, and we'll go ahead and show the elements. Okay. And we can see with my boundary conditions, this edge is being held vertically. Okay, so that it cannot leave this plane, but it is allowed to travel in the vertical direction, and it did. This edge had my applied moment on it, and I believe it was this lower edge. Let's see, something must have been prevented from moving. No, it looks like I removed the nothing can move constraint, and I simply applied my moment to this surface, because it looks like maybe there's a line along the center that didn't move, but I don't recall constraining a line along the center so that it couldn't move. So we'll take another look at that, and we can see this thing is definitely being bent by the moment, and this section is showing typical beam bending behavior with regard to the stresses. I believe we have enough on this video.